So what is this fully managed Kubernetes control plane? Here it says this is a managed service that makes it easy for you to use Kubernetes on AWS without needing to install and operate your own Kubernetes control plane. Like we learned, there is a control plane, right? The master nodes. Managing the control nodes for their high availability is a very big challenge. So we have to maintain the high availability of the control plane, because if control plane or master node is down, entire cluster would be down. So it would be a real challenge to maintain the high availability of this control plane or the master nodes in the reality. This makes sure, this managed service makes sure that it provides or it installs and it manages the control plane. We need not do anything for the control plane. If you remember in the Kubernetes setup, I have installed them, right? I have installed the KubeAdam, Kubelet, kubectl. Of course, kubectl you should have anywhere. We have installed all the components. We made sure that kubelet is running, and we have to make sure that master will be running. If master server is gone, cluster would be gone. So we have to take care of all these things manually. But this managed service helps us achieve all of that. You need not do anything for the control plane. See here, control plane pricing is different. Right. So how much this control plane costs? EKS cluster costs 0.10, like 10 cents per hour for each Amazon EKS cluster you created. Right. Apart from this, you'll also create worker nodes, right? So you'll be charged separately or extra for those worker nodes. And also again, if you create load balancers, that will be an top up over that. So all of this pricing you should take care of. Means control plane, the master node or the whatever you call that is that has a separate pricing. This is the pricing of this control plane or master. And for the AWS resource you create to run your Kubernetes worker nodes. You only pay for what you use as you use it. There is no minimal fees, there is no minimum fee or upfront fee. You pay for what you use. But even then, let's suppose I don't have any worker nodes, only I have created EKS cluster, still you will be charged for this control plane. And again, later, if you add two worker nodes, you'll be charged for those two worker nodes. Worker nodes are nothing but EC2 instances, right? Which type of EC2 instance you choose, it all depends. And above that, if you create some load balancers or if you create anything else, those are all above that. And here is the EKS documentation. A clean and good documentation is available. So see here all the contents. What is an EKS? It is a managed service that you can use to run Kubernetes on AWS. If you want to use AWS Kubernetes on AWS, you can use this managed service. You need not use kubeadam and all. But last setup we assume that it was a kind of on-prem and we have created it. Otherwise, you could use this without you need to install, operate, maintain your control plane. You don't need to install control plane. You don't need to manage it. When you create EKS, at the backend control plane will be created, and this managed service will take care of this control plane automatically. Right? Runs and scales the Kubernetes control plane across multiple availability zones to provide high availability. Automatically scales control plane instances based on load, detects and replaces unhealthy control plane instances, and it provides automated version updates and patching for them. Right? And then the control plane architecture, like how the control plane works. See, this control plane runs a single tenant control plane for each cluster. You mean like it will have a control plane at the back end. You don't need to worry about where is this control plane running and all the share will be all the load like containers or pods will be shared across the worker nodes. How Amazon EKS works, everything you have here. Deployment options, how do you create it? Again, the hardware, everything you have. You can provide the AWS, that's a different part, or else generally we provide the infrastructure from AWS. So let's suppose if you want to create Amazon EKS, obviously you should have kubectl. Like I already said, irrespective of how you're creating cluster, kubectl is required. It's a command line utility. For you to interact with your Kubernetes clusters, kubectl is required. And then what is this EKSCTL? Elastic Kubernetes Service Command Line Utility. This is for managing EKS clusters. Meaning, see, you can create a cluster in two ways. One way is like you have this way, you go here, you create a cluster from the UI, you click this, give some name, configurations you want, and create a cluster. That's one method from the user interface, right? Which is not a great option because you cannot reuse, means you cannot reuse the steps. If you want to do it again, you have to do manually. So there comes the CKSCTL command line utility tool with which you can create or manage your EKS clusters, right? That's from CLI. So from CLI, you can spin up your cluster. So, but to use this EKSCTL first, you should have AWS CLI. Do you remember AWS CLI? It comes by default for all AWS instances. On Windows machine, if you need, you can install it, right? So let us install this AWS CLI first, right? Then EKSCTL, and let's spin up a cluster. You can do it from, let's take another EC2 instance. Okay, from that EC2 instance, on that EC2 instance, you can install all these tools and then spin up a cluster. Or else you can, from your Windows machine, you can do that, right? Like I said, you don't need to jump into the cluster and do it from outside the cluster. Like you can create a cluster from any other remote machine, connect to it. So let's look into that part. Till now we were logging into master node and did everything, right? You can connect from outside as well. Okay, let's connect from our local machine, right? Here you need to have, you may use git bash. Here you should have kubectl and ekctl installed. How to install kubectl? Very simple. And again, all the steps will be available here. See, installing and updating kubectl, installing and updating ekctl, AWS CLI. These three should be installed. See, this is the command. These are the commands. Install or update kubectl. Depending on the operating system. If you are doing it on Windows laptop or Mac or Linux, you can go for it. Right here are the commands. ekctl also. Installing kubectl. It was showing the official documentation for ekctl. Right from here, you can install. How to create a cluster was also there. Right. So for Windows, here are the steps for installation. For Windows, you can use Chocolatey Package Manager also to install ekctl. For that, again, you have to install this Chocolatey Package Manager. All these steps will be there in the drive. Right here are the steps. Depending on your OS, you can install this. Sorry, this is for Windows. You can install them through PowerShell. PowerShell commands are here. These will be there in the drive. So these three should be there. Remember, ekctl, kubectl. Kubectl straightforward steps were available here. For EKSCTL, you can install it through Chocolatey. Installing Chocolatey packages commands are there. And AWS CLI we have already seen. So if it is your laptop, Windows laptop, so this is how you can install from the command prompt. Right, all of those should be installed. Let's see if I have all of them. kubectl version. Right, so it is available, it is installed. And let's check for EKSCTL. Right, even this is available. AWS version. AWS install, that's why it was showing you all this help and all, but still, yeah, this is the version you can see. So all these three components are installed. Once these components are installed, it's very simple to create the cluster. Okay, first I'll run the command and then I'll explain the command because this will take 20 minutes or so to create the cluster. So first let me create the cluster. I'll run the command, then I'll explain what it is. Okay, I'm running it. Meanwhile, something gone wrong. Create stack already exists. Okay, there was some cluster with this name already. So now what is this command? See, EKSCTL create cluster. That's all. It will create the cluster. But if you want to provide the name, right? Name flag, version of the cluster, right? Version of your Kubernetes, and then region, in which region you want. If you don't provide the region, you can do AWS configure, right? When you do AWS configure, it will ask for access key, secret key. So in that way also you can do. And then node group name, right? Like worker group one. What is this node group? See, you can create different node groups. Just 1 second. Here, if you are creating cluster, you should see something here. I wonder, okay, yeah, here is your cluster. All right. So what is this node group? You can have multiple node groups in your cluster. Node group is nothing but this one. Node group is nothing but combination of worker nodes. Means let's suppose some worker nodes you want Ubuntu nodes. Some worker nodes you want CentOS nodes. That is also possible. You can create different node groups, right? So node groups will have, node groups means worker nodes which will be coming from same AMI and same type. AMI, you know, right? We have used Amazon Linux too, but here I did not mention the AMI. Yes, you did not mention the AMI. If you do not mention the AMI means it will be using Kubernetes optimized AMI. Means the AMI which comes with Docker and other pre-packages which are suitable for Kubernetes. Right? So you can choose the AMI, which is optimized AMI. So that's why we did not mention. Always preferable to use that optimized EKS AMI. Otherwise, if you want to use something else, then there is another flag where you can mention the AMI. Node type, T2.medium, right? You can put as you wish. And number of nodes. I want to start a cluster with one worker node. Nodes means worker nodes only. And when I am going to implement auto scaling, I want to scale down or else put a minimum number of one, maximum 5. This is desired. It will start with one. Automatically, auto scaling will not be there. You have to configure it. Once I configure it, I want to put, means whenever it is scaling up and down, I want it to go till minimum 1 and maximum 5. Manage means manage Kubernetes nodes. Means all this we are using optimized EKS MA and the Kubernetes EKS service will manage this control plane. We have nothing with the control plane. Are you seeing anything with the control plane? See, waiting for the control plane to become ready, but you never or you can't see it. It is at the back end. You only see your cluster here. That's all. It's in a status creation state. All these components should come up and the worker node should come up here. See, this cluster do not have any nodes. Nodes means worker nodes. Node groups, no node groups, because it's still coming up. It's still creating. Understood, everyone? And where is this optimized EKS information and all? Yes, it will be there in this documentation if you go over creating a cluster. See here, creating cluster can be done in multiple ways. To create image in EKS cluster, you may create with EKSCTL from management console or use AWS CLI also you can use, right? So yeah, just region and name also will do. It will create the, this is for connecting to the cluster. This is the next thing. Um, Platform versions, yeah, node information. Yeah, managed node groups. What is meant by managed node groups? Creating a managed, we created a managed node group. How to launch managed node groups that register. After join the cluster, you can deploy Kubernetes. If this is your first time launching, I recommend you to. An existing EKS cluster. This is how we created. Here, EKS optimized managed Linux AMI. Yeah. See, each AMI release includes various versions of Kubelet, Docker, Linux, Containerd. All of them will be coming up with those managed AMIs. You will also have somewhere which AMI it's using. This documentation we should go through to see all of that information. Manage node groups information. Yeah, here EKS optimized. You can deploy with pre-built Amazon EKS machine images or your own custom AMS. You can create your own AMIs or else use the optimized EKS AMS, right? Like what are Amazon machine image? No, it's about AMI. Optimized AMI. You may create them with some scripts and use those AMIs also. But always preferable to go with the optimized EKS AMIs. Right? Amazon Linux AMIs. Instance types. We were choosing the instance type, right? There were different family. We were choosing T family, general purpose. Right? There is a lot of things you can refer. See, it's still creating. Let's go to the UI. My cluster. See, it was still in the creating state. Node groups were not created. Once node group is created, you will see an instance here. Any questions in this part? Any questions from anyone? So this cluster should be created. Once this is created, if you remember, whether you create a cluster on EKS or on-prem, whatever it is, there will be a file called kubeconfig created. Do you remember? Whoever have access to that kubeconfig file can connect to the cluster. Obviously, as I'm creating cluster from my laptop, I can connect from here. Now let me show you that kubeconfig file. It might be still creating as we are using it. Yeah, this is the one. .cube folder and the config file, right? It was being created some days back, but by the time cluster is created, you should see the new one. Or else what you can do is you can delete this kube config, it will create a new one. That's old one. Let's wait and see. That's a kube config file required to connect your clusters. Let this complete. So once cluster is ready, either you create it in the previous method or this method, the way it works is same. Means you deploy the manifest files, you run the, you put the deployments, whatever you need.
Pretty in real time, who will be deciding the minimum nodes and maximum nodes and the type of the node, like which is a medium, micro, or
Like the architect, application architect will give the information, like what is the size of the application, how many nodes you need. At the design level, all this will be.
so this command will be running by us or is by the architect itself?
DevOps persons, architect will give the design. DevOps
Permission.
team create the cluster.
Okay. So EC2 instances will be used or else any some other instances will be used.
C2 instances will be used when you are using managed service, EKS. There is also when you are creating EKS cluster, either is something like EKS anywhere. That's a new service actually. With EKS anywhere, again, control plane will be created by cluster, but worker nodes could be your on-prem servers. That's a new feature actually. I don't think anyone is using it. It's not stable or it is maintenance is super costly. So we don't prefer it. If you are using on-prem servers, we are creating on-prem kind of setup with Kubad. But yes, AWS says there is an option, but which is again very costly. Maintenance is costly.
But in real time, the companies will be using EKS or bare metal architecture.
KS, majority KS, but because of the cost now, small companies were slowly drifting to on-prem kind of setup. Some companies.
Okay. But almost all the MNCs and product-based companies will be working on EKS itself.
That's what I'm saying, right? It depends on the budget. In small companies, let's say some projects may be using EK, some may be using on-prem, depending on the client and so many other factors. Let's say some clients they don't have high SLAs. They may be on-prem. It all depends. But majority of the clusters in general, overall, in general, were on EKS. But slowly, like I said, to minimize the cost, some of them are moving to on-prem as well. But most of them are in EKS. So you should have idea on both of them. We can't decide this company is using this or there's no hard and fast rules. Yes, cluster is almost ready. See node group, worker group, and that's the name I have given. It was being created. Once it is created, you should see a node coming up here. Let's wait.
Preeti, whether we can add the additional worker node in later stage with a
We
different size?
Yes, you have a EKS updating a managed node group. Upgrade node group name, cluster name, region. You can upgrade the version as well as the type also.
Okay, and here we don't have any control on control plane, right?
Yes, we don't have
And
any
how the billing will happen because we don't know what kind of machine they're using for the master plane, right? For the billing.
standard billing. You are not, you don't have an option or you will not have any control on the control plane cost. Like this is again important from the point of interview as well. Like if you want to minimize the cost of EKS, you have nothing to do with the control plane. You cannot minimize or reduce. You can't do anything for it. Control plane cost. Where is it? Some time back I have shown you. Huh. This is fixed. It's not saying as per the type you choose. You pay this one for Amazon EKS cluster you create. That's all. And for the AWS resources you create, that's for worker nodes is like additional. Control plane cost is fixed. You can't do anything. You can do, if you want to minimize, optimize, you may choose different types of worker nodes. That way you can.
So it will be billing every time this like per hour $0.10, right?
Yes. Yes.
Okay, so we can't go for serverless, right? In this case.
Serverless is different. Serverless means worker node serverless, not the control plane serverless. Control plane EKS is costly. EKS server control plane is always 10 cents per hour, whether you create EC2 instances or whether you go for serverless. Serverless means, to avoid confusion, let me explain serverless. Serverless means your worker nodes. See, we are creating EKS worker nodes, right? I have created one. See, it got created. One worker node. And maximum is 5, minimum is 1. Means when I scale out and scale in, it can scale into 1, scale out to 5 worker nodes. Okay. There is another option. This is managed node groups. There is serverless, which is called Fargate. What is that also? I'll show you. See here, when you go to compute, Fargate profiles, I'm not using it. What is meant by Fargate? If you use Fargate cluster, Fargate means it is called serverless. Again, what is serverless? You will not create EC2 instances like this, whereas it will create the worker nodes by itself depending on the load. Let's say I put 10 pods. Depending on the load, okay, how much resources are required for this 10 pods, it will create those resources. That's all. It will not create EC2 instances, but it will create the resources by itself. And it will scale out or scale in accordingly. That's called serverless. You will not have control over those underlying infrastructure also. Here, at least I have control on EC2 instances. I can choose which type and all. But in Fargate, you don't have it. That is called serverless. Even that will be charged. But yeah, you don't have again control on it. There will be somewhere Fargate cluster. Then see, actually the cluster we created is called semi-managed cluster. Means control plane is managed by EKS. Worker nodes I am managing. It's a semi-managed cluster. So a Fargate thing is fully managed cluster. You don't have control on anything. Creating a cluster with the Fargate. Managed, updating. See, self-managed. This is again much more self-managed means more control. You have to choose your own AMI, your own EC2 instance. See, this is Fargate. We are using managed node groups, right? Means the worker nodes we are controlling, but still it's using optimized AMI. Self-managed means, see here, Amazon Linux. You will choose the worker nodes. Auto-scaling Linux, so that is after nodes join cluster. Self-managed Linux node with EKS ATL. Yeah. See, managed is false, right? You will manage your cluster. And the Fargate. Please keep muted. A Fargate type of cluster. Yeah. You have to create a Fargate profile, right? Some with some labels and all. This is how you create a Fargate. Create Fargate profile with some permissions, with some roles for the pods. In which subnet you have to create some options to it. That's a Fargate profile creation. See, in Fargate, these are the instances it's being used. Anyway, that's actually the serverless. Coming back, cluster is ready. Here you should see everything. This is the node. See, node is ready, worker group. In that, see, this node is in the worker group. If you just click on this, it tells you this is the instance. Let's go to this instance. It's nothing but EC2 instance page, which will show you this instance, which I'm showing this one. See that particular instance details, all the details of that instance, right? If you click on instances, this is the one, right? And here you can see 2 cores because I've created T3.medium, I think. So 2 cores, memory available, how many pods it can run. There might be some default pods. It was showing all. See default pods, core DNS pods, AWS node, kube proxy, default pods were running, right? This is your cluster. So how do you connect? Because I have created cluster from here, it says control plane. I mean, cluster is ready. And it is also saying here is your kubeconfig file. Some time back, I deleted this kubeconfig file, right? But this came up now with our system date. And if you want to see what is present in this, right? This is your cluster. API version, the cluster, CA. This is called certificate authority, server endpoint, cluster name, right? And so on. The config details, everything you have here. So this is required to connect from anywhere. Suppose you want to connect from any other remote machine, you will need to have kubeconfig. Anyway, because I have this kubeconfig, I can connect. So commands are same, whether you create a cluster in the old method or this method, commands would be the same. Okay, one worker node is there. Get pods in the default namespaces, there might be some pods. Right, the default pods were there. Let us deploy some pod and the service just to quickly show you how it works. Everything is same, okay? Let me create quickly a manifest file. Whatever features we missed earlier, we can see here. Okay, I'm just creating a simple deployment and I don't need a secret because already I have done AWS configure here. Okay, I'm just commenting this part. We'll see this build number and all. Okay, what is this? I'll tell you. Here it should be, let's say I'm deploying PHP, okay, for now. And this will be port 80. HVC1, Java Maven app, it's port 80. Just I want to show you load balancer service as well. Okay, type load balancer doesn't work earlier, right? So let's see. Apply -f Kubernetes.yml. Okay, it says all of the objects were created. Let's see. Get deploy. Get service. Yeah, this is important. Do you see that? Earlier, this external IP was not generated. When I discussed about load balancer, I told you it will create a DNS, right? This is the URL or the DNS. See here, elb.amazonaws.com. You can also change it to some URL. That's the next part. Okay. So here, if you go instances, load balancers. Whenever, so how it is creating at the backend, see, this is the endpoint. It will create a load balancer by using cloud native load balancer service. These load balancers are again costly, right? You will be charged for these load balancers. But here are all the details. Just let me go back. Right, this is the one. This is the DNS. This and this both are same. Okay, on this DNS, you should be able to see the application. But here we can't see that because pod is not running. Yeah, because of the private registry, we have to configure that. kubectl get pods. You have to create the secret, right? And apply it. But otherwise, yeah, this is here. Let me put some dummy image over there just to show you quickly the load balancer service. Okay. Okay, it was running. Now, this is like a URL, right? The DNS. Do you see that? Understood, everyone? The same way ingress also. This would be the ingress URL. Slash cart means you will see one service. Slash products means you will see other service. Path-based routing is also possible. Got it? So that's a load balancer service. As simple as that. But this is costly. You should delete it once you are done with it. Right? So we know how to deploy on this EKS cluster. There's nothing new. So what is new now? What shall we do? Shall we deploy it from our Jenkins? Yeah, that's a point, right? When you have the pipeline from the Jenkins, we should be deploying this Kubernetes. I mean deployments on the Kubernetes cluster. Means we have done CI/CD pipeline where our pipeline is deploying the Docker containers. Now the pipeline should deploy pods onto this Kubernetes cluster, right? So let us proceed with that. Let's create a actually, our Jenkins is on the other region, isn't it? Let's see. Let's go to our Jenkins server, which is on other region. Whether it will connect or not, let's see. Actually, here is our Jenkins server in AP South 2. This is where we have Jenkins. Let me start this. See, from Jenkins, I would like to create a job. That job should deploy something on this Kubernetes cluster. Agree, everyone? This connection, this pipeline is very important. Okay, let us first start Jenkins and let's go to the Jenkins page. Let's start Jenkins. Okay, so now I want to connect from here, right? So to create a job means I want to connect from here. First, let's test from the CLI of this Jenkins, right? Let's test from here. If you can connect from here means you can connect from the job, like your job can run, isn't it? So just let me check. You should have kubectl installed on this Jenkins, isn't it? This is Jenkins master. Let's suppose you want to run a job on slave. Means from whichever machine you want to connect to this cluster and run kubectl, on that machine all these tools should be installed. Am I correct? Am I making sense or is it confusing? See, just simple logic. Let's suppose this is the slave machine. On this, let's say Jenkins slave or master. Okay, this is Jenkins slave or master. Suppose I want to run a Maven compile job on this slave or master, whatever it is. What are all the tools you need? You need to have Maven, Java, Git, correct?
Yes, Preeti.
Yes.
Yeah, we need all of them. Similarly, now on the from a master or else from any other machine, I want to connect to this cluster and run these commands, whatever it is, or else I want to do apply -f some file, whatever. So what are all the tools I need on this Jenkins slave or master or whatever machine? Correct? I should have kubectl first. Then I should have that kubeconfig file to connect to the cluster, isn't it? These two are definitely required. Kubeconfig file because so that I will connect to the cluster. Of course, AWS, like on Windows, whatever we did, all of them should be there. Of course, EKSCTL you don't need to have because you are not creating. EKSCTL is for creating, updating, or deleting your cluster. If you want, you should have it also. Otherwise, you should have AWS CLI, kubectl, kubeconfig file. Agree with this, everyone. That's what we did on Windows machine. Similarly, now I want to apply from here through the pipeline. Means I on slave or master, from wherever I want to run, I need these tools. Correct? So let's check if I have kubectl. I don't have it. Let us install this. We have seen steps to install this some time back, right? Installing. Yeah, installing kubectl. Okay, it is now Linux machine. So go to this Linux tab. Here are the steps. Okay, we were using 1.23 cluster. You may install this one or any version is fine. I'm installing this. I'm running this job on master only. So on the master machine, I'm installing it. Second step B is optional. And third step, provide the executable permissions. After providing the executable permissions, creating this path. Then this is optional. And then we should be able to check the version. Okay, so kubectl is installed. Now I would run kubectl get nodes. See, kubectl is installed, but you should have authentication to it, right? So, okay, we'll do that. Before that, first AWS CLI should be there. Anyway, it will be there because this is easy to instance. AWS is there. First, let's connect. AWS configure. Okay, it was already there. Region, actually, our cluster is in South Mumbai. So maybe I would put here AP South 1. Okay, now I need this kubeconfig file as well. One way is create here a directory like you have dot docker. You remember we created dot docker and put dot docker config file. So create a directory dot called kubeconfig and you do it. Or else there is one more method to do. This is the command. See, if you created cluster using EKCTL, already completes have been able to communicate by adding kubeconfig file. Yeah, we can use this EKCTL to update this. I don't think it will work on the EC2. Let me check. See, you can update the kubeconfig file with this command. Creating or updating kubeconfig file with this command. Let's see. Go to that Jenkins. change the cluster name. Cluster name is, yeah, my cluster only I have given name. Region is AP South 2. AP South, oh no, South 1 in Mumbai, I have created the cluster. And that's all. Let's see. That is AWS CLI command actually. Yes, this is working. This is AWS CLI command. So it has created the kube config. Let's see. You can do it manually. See, you see that? The same way you will have the config file created with this command, right? Which we have seen on Windows. So yes, now you can connect. You may run kubectl get nodes. Perfect, right? So Jenkins server is able to connect to it. Means it can run any commands. It can run get nodes, means it can do get pods or get whatever. It can do the deployments, anything it can do, right? So see, so perfect. Let me delete old ones, okay? kubectl delete deploy one. I think it was, no, it was Java Maven app deploy name. Java Maven app. Okay, service also I would like to delete. Delete a service. What is the service name? This is the service one, is the service name. Okay, service one. Okay, just the cluster is much more cleaner. Okay, fine. From Jenkins server, I can connect. Let us also see, create a test job if we can connect from here. Isn't it? Just making sure before integrating it in the pipeline. Kubernetes test job, a sample freestyle job. I would choose the build step execution. So kubectl get nodes. Okay, any command if it can run means it can run anything. So just let me try this out. It failed. What it's saying? kubectl command not found means it could not identify this because we are running as a Jenkins user. To make sure it works, what we can do is, where is kubectl or which kubectl? See, it's here. Maybe we can do configure sudo get nodes. Means calling this kubectl from this path. Okay, it is available here because it can't identify this executable. So calling from the path directly. Now, still error. Console output. We don't have permissions. It was saying as it was, we were checking from the root. We might have copied this to USR local bin. Let's do one thing. Here, actually, here is the binary, right? Binary is in this path. Root, okay, slash root. Let's copy this to USR local bin. kubectl to USR local bin kubectl. kubectl version. Maybe it could check kubectl get nodes. Now configure. Let me try now. kubeconfig file is available here. Now it was identifying, but yeah, because I'm running as root, it doesn't have access to the server, doesn't have. It identified kubectl now, but the thing is, it could not, like, it doesn't have the kubeconfig file, right? Let us do one thing.
Preeti, whether it is running as a root or a Jenkins user,
Jenkins user.
then that user may not be having the permission to run kubectl or.
It has permissions to run kubectl now as we move to USR local bin, but the file, like kubeconfig file, is not present with this user, right?
Okay.
So I'm updating kubeconfig for this user also. The region is, it is present in AP South 1. Let me check now. Update to local. You can configure credentials by running. Again, AWS configure should be done by this user. What we can do is, we are doing this as a root user. First, let me check with EC2 user. EC2 user, kubectl get nodes. See, it has kubectl, but kubeconfig file is missing. So AWS configure is not done with this user. AWS credentials. I don't think these are the right credentials. EC2 user, it's working now. This is Jenkins user. If I run with sudo, USR local bin kubectl. Let's see sudo verse. I'm adding Jenkins user group. To run the commands without prompting for the password. Right? No, it worked. So now Jenkins can run any commands. For Jenkins application users, I have given the permission, so it was working fine. Right? So now this can deploy the manifest file. So let's go to our pipeline to continue. Where is our pipeline? This is the one, I think. What are the stages we have created? Deploy, and for deploy, we were having a permission, right? Let me check which pipeline is this. We'll add the new step here. It's address book.get and it is develop branch. Okay, let us go to this repository. It was about develop branch. Develop Jenkins file. Yeah, do you remember this? Yeah, we have package and we were deploying it, and I think we have done other stages as well, right? Compose stage is completed. Have we added Docker Compose in the pipeline? Yes or no? Have you completed your hands-on?
No, Preeti, I think I stuck here somewhere while doing it.
Actually, Compose will be present in PHP DB, not here, right? Do you deploy Java Maven app with Compose? No answers from your end, from anyone? We have added Compose stage for PHP DB application, isn't it? This is the one. Have we done this or not? At least I'm not seeing any response from your end.
I tried Preeti, but it did not go through. Somewhere it
No,
stuck actually.
no, in the class. I'm asking in the
Yeah, class it is done, correct.
Compose is completed, right? So
Yeah,
I'm asking for confirmation.
yeah,
Yeah,
that's done.
Compose we have done. So now the next step would be integrating it with the Jenkins, right? Let's integrate it with Jenkins. See here I'm placing the Java Maven app here itself. But here the point is we don't want to hard code the image name, isn't it? The pipeline is like every run, it will pull, build the image, right? This is your Jenkins file. You will pull, you will build the image, and then you'll push to the registry. Once it is pushed to the registry, how you want it to deploy? I want it to deploy. Earlier we deployed as Docker containers. Maybe it's test environment, but let's say now it is production. I want to deploy it with Kubernetes. So here these steps changes, isn't it? So this is where I need a change. Here actually, 1 minute, let me check the server config.sh. Installing all the tools, MVN package, then what is server script doing? See, installing Docker, starting Docker and deploying it. All of this we have seen, correct? Can you confirm me in the class we discussed all of this, right?
Yes, Preeti.
Now, yeah, now today's part is like we have deployed them to Docker. See, packaging the code on a slave machine. And then we have done deployment also. Let me take you to that branch also. This is develop. Maybe we might have used develop CI/CD. Or what is the branch name? Can you recollect? Or dev branch. Yeah, I think this is the one, right? No,
I think CI/CD Docker.
this one?
Yeah.
Yeah, I think so. Yeah. Correct. So 2 weeks back. Yes. Right. This is what we did. Image name and yeah. Correct, right? And also we have deployed it. Yeah. So this is what we did. We deployed this way using Docker run. Right. On the deployment server, we have deployed this way with the manual approvals. We have done this deployment to deployment. Now this deployment phase would be changed where we'll deploy through the Kubernetes. Okay, for that, let's take this branch. Above this, we'll make some modifications. Okay, I think this code is available with me. Let me open this folder. Okay, git checkout Docker CI/CD. Okay, this is the branch we were talking about. Okay, this is the Jenkins file we have created. Yeah, I think now you can recollect. So we were calling some script, just I'm trying to recollect the things. Yeah, it's a compile, then unit test, package, build a Docker image, push to Docker up. Right, everything we were doing in the Docker file, I mean through Docker file itself. This is a Docker file where we were build. Is this a Docker file? No, right? This is not the Docker file. Docker file is where we were using Maven to build. Am I correct? Let me get that Docker file. This is the one, isn't it? Because I did not pull the code from here, it was showing the later. So let me pull the code. Git pull horizon. Okay, now let me check the Docker file. Docker CI/CD. Is it Docker CI/CD branch? Oh, CI/CD Docker. Oh, give me a second. I'll clean up all of this today. Okay, don't worry. I'll clean up the repositories and put only the working branches. Yeah. Okay, this is the Docker file, correct? Initially, we created Docker file that way, a simple method, or else this is the one. Clear, everyone? Is this the Docker file we have used? Yes or no? Please confirm me.
Preeti, I think we did not use this.
Did not use this Docker file?
I think so. We did not use.
Okay. Then is this the pipeline correct?
Yeah, this one we used.
Give me a minute. If we use it this one, see we install git docker.
There is a Docker compose file as well, right? Somewhere.
Where is it?
No.
This is our July playlist, right? Docker integration, right? This is about the Docker file. Instructions, explain Docker file for PHP Docker Compose integration. Java Maven app. This is Docker part. Volume, spine mount. This is Docker file in general. Docker files for PHP app. Docker Compose integration. The job is correct. Is this the correct job we were looking into? This is not the one. This is the one, right? It's add book job, package and deploy. Okay, it's on V2. CI/CD Docker on address book V2. CI/CD Docker on address book V2. Okay. Correct. This is the one where we integrated Docker. Server config.sh, where we are installing Git. Here the Docker file. We discussed it was this file here. Docker file. Server script config. Installing Git and Docker. See, installing Maven is commented. Java is commented because we packed everything there. CI/CD Docker. Can you recheck? Have we covered this Docker file or not? We should have been covered because this is the one here. CI/CD Docker. Can anyone recollect? Have you tried doing hands-on on this Docker file or not? Volumes, bind mounts, backup, Docker file for Java Maven. See, we discussed this. Okay. Yes. Can you see now? Can you all recollect? This is the Docker file we have discussed. July batch, your batch, Docker 4th session. So visit this session. If you have missed this Docker file, we have discussed this Docker file. We have packed everything in the Docker file for Java Maven app. At least can you recollect by seeing this?
Yes, Preeti.
Please recheck, okay, if you have missed or if you could not recollect, redo the things, okay, do the hands-on. And now coming back, this is our pipeline actually. This is where I have created pipeline in address book V2 project. Okay, I'll mark it down now so that to avoid confusion. This is the pipeline. CI/CD Docker is the one we were using. Okay, fine. Again, the same was pushed to address book also. Both were same CI/CD Docker branch. Anyway, okay, this is the pipeline we have created in the last session. Address Docker Compose is for PHP-DB. Here we don't have PHP. I mean, here it's not microservice. So we have deployed just with Docker. Docker Compose we have used for PHP-DB. That also we'll see how to deploy it to Docker Kubernetes. That's next part. Now, here we were deploying this way, Docker run. Now I will remove this step and put kubectl apply command. That's all. Only the thing is, In this repository, I should put that Kubernetes file and I should put that kubectl apply commands. Right? We shall do this tomorrow. Okay. You also revise from your end. What you have to revise is revise your Jenkins pipeline. Okay. It is in the address book repository. Here in the CI/CD Docker branch, both are same. Okay, go through the Docker file once again, go through how you created Jenkins file. Pipeline is important. Go through this pipeline before you join tomorrow. Okay, we shall take up from here in the next class. Any other questions from anyone? Visit Docker 17th, I mean day 17th and day 18th sessions before you join tomorrow.
Sure,
We'll
Preeti.
close it here and we'll continue from tomorrow. Thank you
Yep.
all. Bye everyone. Any more questions you can ask?
Yeah, Preeti, one help, Preeti. Actually, for that, this one Docker secret key you are generating, right? Can you show me once, Preeti, how you are generating, because I missed
Tomorrow
that.
we'll create once again because see on the cluster we don't have it anyway. We have to create it.
Okay, fine. Thank you.
On this cluster we don't have it, right? To connect we need to do.
Okay.
Or in the old cluster like Kubernetes we did, but here it's not there. We'll create it and we'll create the pipeline tomorrow.
Okay. Thank you.
And one more thing, don't keep your cluster running. It is costly, right? Also don't lag the hands-on like I did today because we just tried to recollect. There is some pause. Don't do that because like it's charged. ekctl delete cluster, name of the cluster, my cluster. This is the command to delete region. AP.
I think sharing stopped.
Oh,
Screen sharing stopped.
oh, sorry. Can you see now?
Yes.
So delete the cluster. Again, deletion will take some couple of minutes, like maybe 10 or 15 minutes, but delete this way so that it will delete all the backend components. If you delete manually, you may miss few things. Delete this way. Again, create it whenever you are doing. Just don't keep it running. Tomorrow before the class, I should create it as it will take again some couple of minutes. Okay. So yeah, make sure you're cleaning up everything once it is done. All right then. Bye everyone. Good day. Thank you all.
Thank you.